Hi, welcome back to my channel. Now we want to discuss functions. The other time we discussed relation as a set of ordered pairs on a Cartesian plane. Now functions, we said functions are special types of a relation. So a function or mapping is a relation in which no two different ordered pairs have the same x coordinate. Okay, no two different ordered pairs have the same x coordinate. So this can also mean that all the y coordinates all the coordinates or the codomain have distinct all the elements in the codomain have distinct elements in the domain. Okay, or you can also say to every element in the codomain there is a distinct element in the codomain, or to every element in the domain there is a distinct image in the codomain. Okay, for example, e.g., consider the set 2, 3, 3, 4, 4, 5. Okay, this is a function because all the elements in the codomain have different elements in the domain. Okay, look at the codomain, the domain, they are all different. Okay, the domains are all different. So this is a good example of a function. Now consider another one. Look at this 2, 3, 1, 3, 5, 3. Close the set. So this is also a function. Why? Because the domain is unique. The domain is unique. 2, 1, 3. That is, no any element in the codomain have the same x coordinate. So this is also a function. Another example, consider the set 3, 2, 3, 1, 3, 4, etc. Now this is not a function. Not a function because the domain is not unique. It's not unique. Okay, so this is not a function because the ordered pair have the same element in the domain. I believe you understand what we are saying. Now, the next thing we want to discuss is how to test for function. Testing for functions. Okay, how do you test for functions? The first way of testing for function is called the algebraic test. Algebraic test. Okay, so if you are given an equation, if you substitute any value of x, you have only one value of y. Then you have a function. So in an equation, if any value of x gives a unique value of y, then you have a function. Okay, so any value of s that you substitute must give you a unique value of y. Then that equation is a function. E.g., consider this equation y equals to 3x. Now, y equals to 3x. When x equals to 1, y equals to 3. When x equals to 2, y equals to 6. When x equals to 3, y equals to 9. Okay, so now the set of solution we have here is a 1, 3, 2, 6, and 3, 9. Okay, so 3, 9. So this is an example of a function. So y equals to 3s is a function because every value of s gives corresponding value of y, which is unique. Okay, that is, no two value of x give the same value of y, so it is a function. So this is an example of a algebraic test. Now let's take another example. Consider this function x equals to y squared. Okay, now when x equals to 4, when x equals to 4, you have 4 equals to y squared, or y squared equals to 4. If you take the square root of both sides, okay, so you have y equals to plus or minus 2, right? So this set of solution will now give you 4, 2 and 4, minus 2. Can you see? So this is not unique. This is not unique because same value of x, which is 4, is giving us two different values of y. Okay, one codomain is giving us two ranges, so which is not supposed to be. So this is not unique, not unique. So we then apply that x equals to y squared is not a function. Are you following? Okay, now number 2 way of testing. The second way of testing for function, number 2, we call it geometric test. Geometric test. So in geometric test, if you have a vertical line on the graph of a relation, the line cuts the graph once. If you draw a vertical line on the graph of the relation, the line must cut the graph once, okay, if the relation is a function. Okay, whenever you draw a vertical line on the graph of a relation, the line will cut the graph once if the relation is a function, but it may cut the graph more than once if it is not a function. So if the vertical line cuts the graph more than once, then the relation is not a function. For example, consider this graph. Example, consider the graph this is y and this is x. Okay, so let's consider this graph 1 1 3 2 2 and another point -1 -1. So plotting the graph of this relation, we have something like this. Okay, so consider this relation. So let's draw a vertical line. So now draw a vertical line. Got the vertical line. So you can see that let's call this relation y equals to x. You can see that the straight line, the vertical line, crosses the graph once. Okay, so that means y equals to x is a function. This is vertical line test. Now another example. Consider this graph. So this is a quadratic graph. Trying to draw a line. This is x, this is y. So let's do the test. So vertical line. Okay, so you can see that the graph here, let's say this is the graph of y equals to s plus 3 s minus 3. So you can see that the vertical line crosses the graph once here. So that means this is also an example of a function. Okay, it's an example of a function. Is an example of a function. So the graph of a straight line will always be a function. The graph of a straight line or a linear function is always a function. That's another thing to note. Take note of that. So the graph of a straight line is a function. The graph of a quadratic equation is also a function. Okay, the graph of a polynomial equation is also a function. So when you draw a vertical line across these graphs, it will cut the graph only at one point. That is, for every value of x, there is a corresponding value of y. So the graph of a straight line, the straight line is unique, and the parabola for quadratic equation is also unique. Another example. Example 3. Consider the equation x squared plus y squared equals to 9. Now let us plot the graph of this equation. We are solving for x. X squared equals to 9 minus y squared. Okay, if you factorize this, you find out to give you 3 minus y into 3 plus y. Okay, so when x equals to 0, you have y equals to 3 or minus 3. Okay, so hence for one value of x, which is 0, there are two values of y. So we now have the coordinates to be x comma equals to 0 comma 3 and x comma y equals to 0 comma minus 3. Okay, so for one value of x, we have two corresponding values of y. So hence x squared plus y squared equals to 9 is not a function. Okay, so how do you know that? If you draw the graph of that equation, so this is what you are going to have. 1 2 3, got this plus 3, 1 2 3 4, 1 2 3 4 minus 3, 1 2 3 4, 1 2 3 4. Good, let's say this is plus 3, 1 2 3 4, this is minus 3. So if you draw the graph of that equation, you are going to obtain a circle. Okay, now a circle here. So it's going to be a circular form. Okay, so if you draw a straight line across it, what do you notice there? You're going to notice that you can see. So the straight lines, the horizontal line, the vertical line crosses the graph at 2 points. At 2 points, okay. So it then implied that the graph is not a function. It's not a function. Okay, so this is how to determine whether a relation is a function. So in general, the graph of the equation of a circle or equation of a circle are not functions. Okay, they are not functions. So this is how to determine whether a relation is a function. You can do the algebraic test, that is, to every value of x there is a unique value of y. The geometric test, if you draw a straight line, a vertical line or horizontal line across the graph of a function, the vertical line will cut the graph once, then it is a function. Then if it cuts the graph twice, then it is not a function. Thank you very much. Please do not forget to subscribe for my next video. Subscribe. Just hit the button. It doesn't cost you anything. Hit the button and I will see you in the next video. The next video will be discussing some notation for function and notations, and we're going to be looking at a lot of examples. So please do subscribe. Stay blessed.